Good evening, everyone. In the last class, I told you about these measures of dispersion regarding the business statistics one continuation. And this is also a continuation for that. In this, okay, I'm going to continue the other formulas regarding this business statistics one. In this, okay, class, I'm going to cover the coefficient of standard deviation, that is how to calculate that. And after that, I'm going for skewness. And after that, I'm going for correlation aspect. And this is completely a formula-based video class. It is not a problematic this thing. Now, in the last video class, you learned about how to calculate the standard deviation in individual series, discrete series, and continuous series. And that values, whatever we have calculated, they are nothing but the absolute measures. Now we are going for quotient, relative measures. So when you go for this, the quotient of standard deviation is equal to standard deviation by arithmetic mean. Okay. Standard deviation by arithmetic mean. When we are going for this calculation of relative measure in percentage, we have to take into account quotient of variation. That is, the other name for relative measure is quotient of variation. And this quotient of variation, we have to tell that in the form of percentages. So quotient of variation is equal to standard deviation by arithmetic mean into 100. Okay. Standard deviation by arithmetic mean into 100. This is the coefficient of standard deviation that was told in percentages. Now, after that, variance. Variance is equal to standard deviation square. And if you want to find out the standard deviation, then you have to take square root for variance. This is about the formula that we come across when we go for standard deviation relative measure. And after that, you'll come across skewness. So what is skewness? A symmetrical distribution that we come across is nothing but skewness. Okay, for example, if you take a bell, both ends of this bell, it will be equal. Okay, so it is nothing but a symmetrical thing. When you go for statistics, arithmetic mean, mode, and median, you have to take into account these two things. And when you take into account the mode is stands high. And before and after that, you'll come across the arithmetic mean value as well as median value. So mode is the thing that divides the distribution, okay, because it is the highest thing that we come across. So when we take automatically both the things, they must be equal on both the ends. So that is nothing but symmetrical distribution. And when you go for this asymmetrical distribution, there won't be one and the same. Okay, either in the beginning it will be high and at the end it will be less. Or sometimes at the end it will be high and at the beginning it will be low. So what is this asymmetry that we come across? All these things we have to take into account and we have to find out. And when we are going for this skewness, we are having two main important formulas. Of course, main methods are three, and out of the three, two are very, very important. So what are the three methods that we come across? SKP, Karl Pearson's coefficient of skewness. Okay, next, Bowley's coefficient of skewness. And then Kelly's coefficient of skewness. What is Karl Pearson's coefficient of skewness? It is represented by SKP. SKP. Okay, so here, what is the formula to calculate the coefficient of skewness as well as its relative measure? SKP is equal to the absolute measure. Mode minus mean. Mode minus mean. Okay, that is the formula that we come across for this skewness. Okay, mode minus mean by standard deviation. It is nothing but the relative measure that we come across. Okay. 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 Mode minus mean is absolute SKP, that is absolute mean minus mode is nothing but the absolute, not mode minus mean. It is arithmetic mean minus mode. I'm sorry for that. Okay, so what is the relative value? What is the relative measure? The relative measure is arithmetic mean minus mode by standard deviation. That is the coefficient of skewness. This is about Karl Pearson's coefficient of skewness. Okay, the relative value is SKP is equal to mean minus mode by standard deviation. This is about the relative measure. Now, after that, you will come across Bowley's coefficient of skewness. Okay, what is the relative measure that we come across? The relative measure as well as absolute measure is, okay, Q3 plus Q1 minus 2 median is nothing but the absolute measure, and relative measure is Q3 plus Q1 minus 2 median by Q3 minus Q1 is the relative measure that we come across when we go for Bowley's coefficient of skewness. Now, after that, SKK, that is Kelly's coefficient of skewness. Okay, when you go for Kelly's coefficient of skewness, okay, SKK is equal to P90 plus P10 minus 2 median. That is the absolute measure. P90 plus P10 minus 2 median. That is absolute measure. Now, relative measure is P90 plus P10 minus 2 median by P90 minus P10. That is nothing but the relative measure that we come across. And we can call this SKK as percentile coefficient of skewness. Okay, percentile coefficient of skewness. And when you go for deciles, okay, SKK can also be calculated in deciles form. D9 minus D1 minus 2 median, D9 plus D1 minus 2 median is equal to the absolute value. D9 plus D1 minus 2 median by D9 minus D1 is nothing but the coefficient of Kelly's coefficient of skewness. So in any way, you can calculate this Kelly's coefficient of skewness. Now, this is okay. This is about the Kelly's coefficient of skewness. Now, after that, we are going for correlation coefficient. Correlation coefficient means when you come across two or more distributions, okay, even though they are different, how far we can correlate them, how far we can keep relationship between these two things, we have to take into account that thing. So that is nothing but correlation. And here when we go for correlation, okay, important of this correlation topic is Karl Pearson's coefficient of correlation. So what is this Karl Pearson, he suggested a formula to calculate the coefficient of correlation. That's why it is termed as Karl Pearson's coefficient of correlation or Pearson's coefficient of correlation. So what is the formula? When you are going for calculation of correlation, one thing you have to keep in mind is, okay, you have to take arithmetic mean first of all. Like how you are taking arithmetic mean when you are going for standard deviation, in the same way, you have to take first of all the arithmetic mean. And from that, you have to take into account the correlation coefficient value. Here, when you go for correlation, okay, what is this? How you will get this? You will get this correlation or degree of relationship by taking into account the covariance of the two different distributions. For example, X and Y. These are the two distributions. And this distribution will have some values, and this distribution also will have some values. And even though they are different from each other, you have to take a degree of relationship between these two things. That is nothing but correlation coefficient. Okay, so when you take into account correlation coefficient, it is represented by small r. And this correlation coefficient, whatever it may be, it should lie between +1 and +1 or -1. That is, whatever it may be, the relationship that we come across, it must be between +1 and -1. Suppose if it is +1, it is a positive correlation. If it is a -1, it is a negative correlation. People, they must understand this. And sometimes when you come across 0, okay, so it is no correlation. That is, there is no you cannot take a degree of relationship between two or more distributions. This is about correlation analysis. And when you go for this correlation coefficient, the formula is, I'm telling straight away formula. Okay, the formula is R is equal to sigma xy by square root sigma x square into sigma y square. Okay, so this thing, first of all, you have to take into account the arithmetic mean. And when you get an arithmetic mean in a rounded figure, you have to take the deviations. Here, you have to take the positive deviations as well as negative deviations as they are, because we are going to square that. Okay, that deviations will represent with small x. And after that, we have to square the small x values, that is deviations. So when you square, automatically you come across positive values only. You won't come across negative values. Then all these, okay, squared deviations, you have to add. So you'll come across sigma small x square. Okay, in the same way, you have to calculate the arithmetic mean of the second distribution, that is bar y. Okay, first, if you take into account x, okay, we are taking the second one as y. So bar y is equal to sigma y by n. And when you get a rounded figure, you have to take that and you have to take deviations from the given values. And it will be represented by small y. Okay, and this small y, whatever it may be, the deviations, you have to take positive deviations as well as negative deviations as it is. And after that, you have to square the deviations. That is, y square, small y square. So when you are squaring these deviations, automatically what will happen is all the positive values and negative values, they will be transformed into positive values. Then you have to add the deviations, that is sigma small y square. And after this, you have to find out the covariance of X series as well as Y series. So what we have to do in order to get the covariance? So you have to multiply the deviations of X series as well as deviations of Y series. That is small x into small y. That is, we can say in one word, it is small xy, small xy. So all these small xy values we have to add. So you will come across sigma small xy. Okay, now you have to substitute the values in the formula. R is equal to sigma xy by square root sigma small x square into sigma small y square. This is the formula to calculate Carl Pearson's coefficient of correlation when deviations are taken from actual mean. The second one is sometimes when we take deviations, okay, the arithmetic mean or the actual mean will be in fractions. That is, you'll come across decimals. When you come across in decimals, what we have to do is we should not take into account the arithmetic mean because we'll come across deviations in different values. That is decimals we will come across. So in order to eliminate the tedious work, okay, in order to eliminate the tedious work, what we have to do is we have to take an assumed mean from the data, or you can take any value from outside. So generally what people will do is they'll take one value from the data given, from the variable values as assumed mean, and they'll take deviations. And those deviations will represent that as the dx by per x series and dy small dy per y series. Okay, same procedure, whatever we have adapted when we come across, okay, the same procedure we will come across. And the formula to calculate is sigma dx dy minus sigma dx into dy by n whole by sigma dx square by n minus sigma dx square, sigma dx square minus sigma dx whole square by n. Here you will have square only for the numerator, not for the denominator. Dx square minus sigma dx square minus sigma dx whole square by n. Okay, here compulsory you have to keep square root. Okay, in the same way, sigma dy square minus sigma dy whole square by n. So the complete formula that we come across is sigma dx dy minus sigma dx into sigma dy by n by square root sigma dx square minus sigma dx whole square by n into sigma dy square minus sigma dy whole square by n. This is the formula to calculate the correlation coefficient, okay, when we are going for assumed mean. Okay, people, I'm telling that people who are going to write this business statistics 1 exam, okay, the easy tips are, okay, business statistics 1 and advanced accounting, they are the scoring subjects. Okay, I'm telling that you please pay concentration on these two things. Thereby, you can clear them. There is no necessity for you to keep backlogs. And you must be very thorough with the formulas. Okay, you must be very thorough with the formulas in business statistics. Unless otherwise you are not very thorough with the formulas, you cannot do any statistics program. Whatever it may be the problem, see that whatever it may be the problem that you come across in business statistics, you must see what is the formula that will come across, because we are having so many different formulas. So all the formulas you must be very thorough, thereby according to the problem given, according to the question what I is asking, that thing you can do when you know the formula. And when you go for advanced accounting, you must know the procedure. Okay, when you know the procedure, whatever it may be the problem that was given, whatever it may be the problem that was given, you can answer that. And the another thing is, when you are going for statistics or advanced accounting, okay, take the problem, read 1 to 3 times, see what information he had given, what information he is asking, and how we have to do that. The procedure, you must be very thorough. And in statistics, you have to keep the steps, step 1, step 2, step 3, like that. You have to write down the steps. And another thing is, compulsory you have to write the formulas. When you won't write the formulas and when you do the calculations part, okay, no examiner, no valuer, they'll take that as granted. First of all, okay, you have to write the formula. When you know the formula, automatically you can know the procedure and you can write the exam in a good manner. These are the things that I want to tell you. And another thing is, spare 1 hour for business statistics and advanced accounting. Whatever subject that you learned from any person, see, I'm not talking about me. Okay, from any lecturer, whatever it may be the subject that you have learned, okay, you must give minimum courtesy to that lecturer, and you have to practice. Every lecturer, they'll say that you have to practice, because it is highly impossible to make a person to climb a palm tree. To certain extent we can, but from that stage onwards, it is you have to climb. Okay, you have to try, you have to practice, because there is a proverb that practice makes man perfect. So with this, I'm closing, and in the next class, I'm going to take another subject or income tax, whatever I have left over, and I'm going to continue that thing also. Okay, until then, have a nice day.